Okay, so sometimes when we're working with square roots, it's really handy to be familiar with perfect squares. So I'm talking about, well, what is 1 squared? It's 1. What is 2 squared? 4. So perfect squares are these numbers over here. Those are perfect squares. 1, 4. Do you know what the next one is? 9, 16, 25. You can go through each of these. This one's 3 squared, 4 squared, 5 squared. Make yourself a little table. I'm just going to do the perfect squares. 36, 49, 64. I'll do this. 8 squared is 64. And then 9 squared is 81. 100. 121. That's 11 squared. I don't know if you knew that one. 144. Let's see. 169. That's 13 squared. I usually go to 15. 14 squared is 196. And 15 squared is 225. Now those are the ones that I'm familiar with, so I just know those, you know. You don't have to memorize them. There's not going to be any quiz. You could use a calculator to find these. But it's just really handy sometimes to be, you know, familiar with some of them. You know, I'm sure some people could go higher than 15. But for me, that's as far as I go. Then I'm getting a calculator. Okay. Or I can break it down into smaller numbers a lot of times. Okay. So let's talk about square roots of negative numbers. So if you had something like the square root of negative 25, we're going to say that this is not real. It's not a real number. Now, that's all we're going to do at this point in this section. Later we'll learn how to deal with them, but it's not going to be it's still not going to be a real number. It's just right now we're working with real numbers, and the square root of negative 25 is not a real number. Okay, so you can just say that. If they were to trick you or there's a typo or something, you could use, like if they're saying evaluate the square root of negative 36, then your answer is going to be not real. Not a real number. Something like that. Okay? So we're going to talk a little bit about, well, what if I had like a really large number that I was trying to figure out, you know, the square root of, or something like that. So let's say I had, what's a large number? Well, let's start with a small number. Okay, so let's say I have the square root of 25, and I want to square that. Well, I can take the square root of 25, right? That's 5. And then I could square it. This is the order of operations. Notice that I'm back to 25. So what if I had the square root of 5.23? And then I wanted to square it. Well, I don't know what the square root of 5.23 is. I could put it in my calculator and it would give me a decimal approximation to so many places. But the thing is, I'm going to be squaring it. So I'm going to be back to that 5.23. I can say that. Okay? You can try it on your calculator. These calculators usually, the scientific ones will remember what the number is. So they won't show you all the places, but they'll remember what it is. So you can play around with your calculator on that. But the idea is, the concept is you're taking the square root of something, but then you're squaring it. So you're doing something, but then you're undoing it, kind of. Okay? All right. This works then right here. If you have the square root of some number a, and a is greater than 0, and then you square it, that's just going to equal, so the square root of a squared, that's just going to equal a. Okay? So hopefully that makes sense. So how would I apply that? Well, let's say I had the square root of 1,134, but then I wanted to square it. Well, I'm not going to do all that work. I'm just going to use the idea here that that's going to equal 1,134. Okay, now we're going to look at this situation over here. Notice that it's written a little bit differently. Here I have the parentheses and then the square, But here I'm squaring something, and then I'm taking the square root. Okay, so let's say we have 4. So we're going to take the square root of 4 squared. Well, because of the order of operations, we're going to do this stuff inside the radical. So 4 squared is 16. And then we say, oh, what's the square root of 16? Oh, that's 4. Okay, so probably what you were expecting, like that's kind of working like what we were just doing a minute ago. But now we're going to change it. Let's say we're going to have the square root of -4 squared. Now, if you're following the order of operations, then -4 squared, you can do that. That's 16, right? And then the square root of 16, that's okay. You're going to get 4. But notice that this does not equal a. Like over here we said, oh, you know, if you're going to do the square root and then square it, it's always going to equal a as long as a is positive. Now you could say, oh, but a is not positive here. Well, yeah, okay, you're right. So now we need a situation for what happens if a isn't positive. Okay, so we have a rule. I guess I have to write the rule. Okay, so the rule is this. If you have the square root of a squared, that's going to equal the absolute value of a. Okay, so then that takes care of any positive or negative problems you have. So if you square the number, it's going to make it positive, and then you can take the square root of a positive number. So this is the rule, and I think that's all we want in this one.